Guys, here we go. These are special composite limits. They look hard, and they kind of are, but don't worry. I'm going to teach you guys how to do this. And the explanation that Delta Math has, I was trying to tell some of the kids to follow what it says, but they were getting confused. And you guys tell me if it sounded confusing or not. So here's what you're doing. It says, what is the limit as x approaches -4 of f of g of x? So first you're going to obviously do the inside one, right? First, the inner. So you're going to go limit as x approaches -4 of g of x. So if I approach -4 of g of x, I want you to notice here's -4, and I want you to notice that that limit is 3. But this is special. Observe that as I approach -4, this is a minimum. All the other y values are bigger. So remember, I have to use this for the next one, right? For the f. So everything is bigger, so that means it's like, so I'm going to do a number line right here. Let's see, where did I put it? Right here. So everything is bigger, the number's 3, so 3. So notice all these numbers are larger than 3. The y values are all larger than 3. So it's like approaching 3 from the right, because they're all larger than 3. Does that make sense to you guys? So I'm going to write limit as x approaches 3 from the right of the outward function, the outside functions of f of x. So I go to my f, and I look at 3, and as I approach 3 from the right, what is that limit? -3. And not everyone at the same time. Does that make sense, guys? Okay, look at number 2. This one is limit as x approaches -3 of g of x. G composite of g of x. So I'm going to do first the inside. Limit as x approaches -3 of g of x. And if you have colored pencils, this is a good one for that. So if I approach -3, and it doesn't, like in this case, I have a continuous function, but be careful also for the open circle. It's fine. Right now I'm calling this a minimum and that one a minimum. But sometimes they'll have an open circle, but it's still just a limit, right? And even though it's not technically a minimum because you're not defined there, but in this case, you're defined. It's nice and continuous. Bless you. So notice that's a minimum, and this limit, this limit is -6. So that's a min. So that means all these values are larger. All these y values, as you approach -6 from the right, as you approach -3 from the right and from the left, all these y values are larger than -6. So here's my little number line. Here's -6. So that's like approaching -6 from the right. So I'm going to write limit as x approaches -6 from the right of g of x, because that's what the function on the outside is again. So as I approach -6 from the right, what is that limit? -4. There it is. Is it starting to get easier, guys? Okay. Here we go. Another one. Number 3. Limit as x approaches. So I'm going to write limit as x approaches -3 of f of x. So I'm going to approach f of x. Here's f of x. Here's -3. Again, I have a minimum. So my y values are converging at 1, but all these y values are larger than 1. So that means if I were to have a scale here or an x-axis here with a 1 there, that's like approaching 1 from the right. Again, I know they all seem like they're all from the right. Limit as x approaches 1 from the right of f of x, because it was f composite of f. So if I approach 1 from the right, that limit is 1. Go to the next page. Don't worry, at least one of them will be a max instead of a min. Again, limit as x approaches -6 of g of x. So if I approach -6 of g of x, here's -6. This is a minimum. So all these y values are larger. So I'm going to draw my x-axis here. I'm going to put what is that limit, by the way? -5. So it's like I'm approaching -5 from the right. So I'm going to write limit as x approaches -5 of this function f of x. It's the outside function. So if I approach -5 from the right, what's that limit? 1. Are we still okay? All right, last one. Finally, something different here on this one. So my bad, guys. Limit as x approaches -2 of f of x. So here I am approaching -2 from the left and from the right. And I observe that that is the maximum. So because that's a maximum, all those y values are smaller than 2. So this limit is 2. So here's my horizontal line. I put a 2. So that is like approaching. So for the next step, I'm going to go limit as x approaches 2, but from the left because it was a max. Do we see that, guys? So, and then what was the outside? Oh, it's just an f again of f of x. So if I approach 2 from the left, what is that limit? 2. Did the explanation that we did today make sense compared to, like, I don't know, did the delta math explanation make sense to you guys? Oh, okay, you didn't read it. You just kind of just figure it out just by looking. Okay. I think we're good now. Did all that logic make sense, guys? All right, then we're done. Take care of business. Take care of your delta. Take care of your notes 1.5. Have you done your notes 1.5? Okay, the delta math 1.5. Take care of that, and we're good, guys. You got